Right, so on that sheet of paper you've got, it basically tells you what we're doing the level check for. Yeah, why do we do it? The screen on there is how to book it all, and a booking field sheet. All right, and then there's some other information on why we do it and how to set up a level. All right, should be there. Right, so first thing we've got to do is we've got to set up a couple of instruments. So I've got a nail between the tarmac and the sets down there at the end of the orangery, and one over here, which you may remember from last year. So that's the survey nail there, yeah? And that enables me to put a staff on there, do a load of readings, change it, move it here, do a load of readings, move the instrument close to here. And the reason I put it in the front is if I've got a staff on here and then I set up, which a lot of the Americans, a lot of other companies do it, they put it behind it, you've got to turn round and then hold it on there. And I don't like that, because if the staff is set up there, there's no reason to change it. You might introduce more errors, because at the bottom of the staff, we'll have a wee look, sometimes it's domed. So if you've got it on the edge, it'll be fine if you're consistently doing that, so you've got it on flat surfaces. But if you put it on a nail or something and it is domed, you could introduce a few millimeters error every time. So again, this compensating error may not work, and you might end up with introducing an error that's unnecessary. So what I'm going to do is I'm going to show you how to, I'm going to do it, put the level instruments onto the tripods, and then with the notes you got in the back, and I've shown you about the left hand thumb, you're going to try and level it while I set up the staff and the forward station. All right? As you look intent. So this is about midway. It could probably go another couple of meters, but I don't want to get in the way of people coming in and out the door. All right. So you just do these up finger tight. The moisture in the air can sometimes affect them. So get it almost level, right? Whack it in there like that. Take the level out his box, stick it on there, and you get a thing under there, tight again, and see if you can level that bubble with the notes I've got in there. So the first thing is that you've got the bubble is this side, there, can you see it? No, here. So I want it to go that way, so I'm going to use my left bubble, right? My left thumb. So I'll bring it over like that to halfway, right?
You're doing both at the same time, so
that's right.
But are you doing the left more than the right?
Not both the same distance. And then just use that one, and I want the bubble to go that way, so my thumb goes that way, and I bring it up like that, all right? And then a little bit more this way, job done. Okay. All right? So you have a go at it then. And I'll set another one over here. Remember, it's the left hand, the direction of your left hand thumb. Right, so I'm going to set this one just here. Just mind your back a bit, thanks. Again, more or less level at the top.
Come on, Michael, can you tell us this is simple because you can't see?
As long as it's within the circle, it doesn't have to be.
We're teasing Michael.
All right. Right. Somebody wants to do this one?
Yeah. Is it on?
Yeah, I've screwed it up. So again, you can move it round. Yeah, but you move it round so that that's parallel with that, yeah?
So what's parallel with what?
The telescope
Yes.
is parallel with these two here. And then you do it 90 degrees, yeah?
How?
But
Well,
it's-
how
it's-
do you know it's these two here and not these two here?
Because we've made it parallel to that, so you're going to move these two at the same speed, but the bubble's going to move
Yeah.
the direction of
Well,
this
hang
thumb.
on. Do I have to do these first if it's actually that
Well,
side?
if you're going to do that one, so the bubble is that way, so I would then
do those two?
no, just that one single one to bring the bubble over this way. So you need to leave it like that. So it's now in line with that one. So now use this one.
You're talking
This-
about the hand or
The left hand on here.
that one? Yes.
So you now bring it towards you, going more. Go on. Oh, no, that's right. So if it was soft ground, it'd be fine.
Yeah. Oh no.
Right, so now it's over this side, so we need to use
Yeah.
these roots. Go back to there. Got that. Both together.
This one can't go anymore now.
Which
Done
one?
this wrong. This one. That one won't move anymore.
All right.
Right. I think
So-
someone else ought to.
No, so we can bring them all up.
I'm going to pay someone to do this. I'm kidding. No, I mean it's weird because what else do I do this on? There's something I use that I do this on.
Right.
Yeah.
So if that was that side, then you could move it both together over there like that.
Yeah.
All right, and then you would move that one slightly over there.
Yeah.
All right. Do you want to have another go at it?
I think I'll
Go on, put it
work it out. I don't know why
And this has got a little button in it when you pull it up, and you know it's clicked in. And that's got when we do tacheometry, I'll explain it, but this is a 5 metre stuff, so it can go up to 5 metres. So somebody was talking about how do we go up the level at the top of that hill. The thing is, you could shoot it there, then you change your instrument, shoot as high as you can,
Yeah.
and the forward one will be slot, and you can work your way by steps going up the hill.
How do you make sure that's vertical?
There's a little bubble in that bag. Can you pass me that yellow bag, IKEA bag? Ta. You can do it two ways. So you can have these bubbles. One of them, you can hold it on the side and make sure it's level, right? Or this one, whop it in the back, right? And then it's level. What I don't bother with levels, because you can lose these, you can bash it off, right? So what I do is just hold it between my fingers, right? And it's going to be
Oh, look for
within a
balance.
minute, yeah. And if you can't, I haven't got a bubble. If that's the instrument, and I move it slowly back and forward like that, you're looking for the lowest reading, because the further away it is, the reading's going to get higher
Yeah.
and get higher. All right, makes sense? Just about. Trust me. Right, so I'm just trying to get this in level.
So this one, the way we make it has to be very straight or not? I didn't get that bit.
Right, it needs that way
Yeah.
is not so critical because you're looking
Okay.
at the centre bit. This way is,
Okay.
because the more it's out of level, the higher you're going to read when you observe it and you want it lowest. So this is more or less in the bubble, that's fine, you don't have to
Okay.
go silly about it. All right,
more or less. I mean that is actually
it's good enough for this, all right?
Is it for
Yeah.
this, but not for a garden survey?
No, it'll be fine, because you're going to be interpolating.
I mean, it is inside. But
Yeah, but you're going to be interpolating 10 millimetre in between there. So you're interpolating between each one of these blocks is 10 millimetres, and you've got to guesstimate where it is. Is it 7 or 8 or a 9 or a 6 or whatever? So if I, whoop, it's me touching it, kicking it. So if I do it exactly level,
Yeah.
you're still going to read it exactly the same.
Okay. Yep. I see
All
what
right.
you mean. Yep.
Trust me, I'm a doctor. Right, so if we go back now, and in there you got a booking sheet, and we'll put down some stations and we'll observe this, all right? Right, so that station's going to be called A. Right, it's called A. And then the next line you put a B, and the next line you put an A, all right?
Where?
Is there something on this or not?
Yeah, it's on the back.
Anyway.
No, next sheet,
Next
it's on the
sheet.
back.
I'm sorry.
Hands are too cold.
I know. It's on the back of one of them.
I know.
That's it. Yeah, all right.
Okay.
So get that in there.
So you put
So I'm going to read this and I'm going to tell you what it is. All right, and these levels have got a circle round there as well, which I'll talk about later. So this is your focus and this is your slow motion. All right? And this is the button I was talking about you press to get that little thing to move. Sorry. So you move it the way. So I'm going to line them up there, focus it. And remember the crosshairs need to be as defined as you can. So you're going to move crosshairs. You'll see it when you look. You want them defined as you can. So you get them nice and sharp. And then focus on the staff. Press the button. It'll float up and down and it'll read 1769. Right?
It will read, will it?
No.
Always. The system's fixed. Always 1769.
Right? So make sure that you're reading that level, because you don't want to read that one because that's going to have different things. So when you're doing this exercise, A, B, A,
Same one.
you're using the same level. So it doesn't matter which one you use, but use the same one.
Okay.
So I'm going to read this one now. Yeah.
1, 7.
Get your crosshairs right.
Okay, I'll look at it a second.
And this one hasn't got a bubble. So this one is that's in,
69.
that foot screws on the front. I'm just going to move it up and down. All right, and it's actually at its end, so you can only move it one way. And the whole image will bounce, and that reads 1717. 1717. Just straighten that again. 1717. Yeah.
In order to read it. Why did you adjust the front system?
Not calibrates, but
Because that one's got a bubble to make the prism move. So if you go and have a look through that, press the button, and then come through this one. The only way you can get that to work is hit the side of the instrument, which is danger of moving it off. Hitting the tripod, you get the danger of putting off level, or flicking the foot screw, and that makes it float up. Just move it one side and back again, and the image will move up and settle, and you read when it's settled.
This is going in back side.
Yeah, that's it.
1769.
No, I don't. You're meant to be reading it.
We're reading.
No, it's 1765 now, definitely.
so what's A again?
A is that station. It can be any point at the end of your
A
baseline.
is where the
That nail,
thing is.
the staff.
There was a nail there, was it?
Yeah.
Yes. So then that.
I'm
going to
go up there. Yeah,
But you leave this
there at the moment until I tip.
until you've done both bits.
Yeah, because what we're trying to arrive at is the error in the instrument. So this is equidistance. This is the similar distance back and forward. So any error in the instrument won't be apparent. How do we expose that? Is we read there, move that as close as we can to there, read that, and then you get 20 times or 30 times the error.
So how far away are these?
This is about 30 metres apart.
So this is how you assess. In the beginning, this is what you do before you start surveying.
Before you start levelling. Levelling. This is levelling.
Yes, you're surveying the site and taking the level.
That's it. So you're surveying the site to fix the detail, the buildings, the walls and all that. And once you've done that, you need to add levels to all that.
Yes.
And this
When you say
exercise.
levelling, it confuses me. It kind of
Difference
makes-
in height.
Yeah, no, I know that, but I feel like when you say levelling, you're
Full start on the backside.
I would have always in the past used that for I'm levelling the garden. Do you see what I mean? Like
Oh,
I'm
what, making it flat?
Yes. I now understand. In this language, it means something
That's
different.
engineering and surveying.
Yeah,
Leveling
yeah.
means.
Getting
It
the
can
levels.
also mean making something
Yeah,
flat,
it
but in
can.
this one it's leveling.
In a
You're
construction
giving
sense.
spot heights to points of detail that you want it.
Finding the levels.
Yeah.
So you measure 20 to 30 max.
Yeah, minimum 20, but basically about 30 metres
30.
between it. You put in
That.
2 nails or 2 pegs with a
Yeah.
nail, something, and you do this exercise
Yeah,
on your
or
level.
You have 2 of those sticks.
It may, yeah, but
You've got them.
well, I did do that before, and it adds confusion because then people didn't know which was A and which was B.
And then you shove this in between, roughly halfway, take
Yeah.
the level,
Take the level,
turn around, set up B, take a level, and then
move the instrument.
move the instrument to
Yeah.
either A
Yeah.
or B.
Yeah, take the level, which is the back sight, and then take the level 4 sight. Once we've done it, it'll show you. So I have
So
taken,
then you've got to move that back. Yeah.
yeah, back to D.
Yeah, back
Goes
to
back
A
to
and back to B. to
Yeah,
get
so that's why you got A in there. So you got
Yeah.
A, that's taking one shot. We're going to take a shot forward onto there. Then we're going to set up the instrument close to it, take another shot, which is back sight.
Yeah.
Then I'll move it way back there and take the original back in
Right,
there.
okay. So-
And that is the one that's the live one. That's the only one you can adjust because that's your last reading. So if there's any errors in this,
Yes.
that's the one you adjust. All right?
Yeah, okay.
All right?
Get there when we've done it.
And the reason being that that's the only one that's. I mean, you could have read these other 1, 2, 3 readings wrong,
Yeah.
reading it and booking it down wrong,
Yeah.
and you've got an error. You've got to resolve that error. So, if it's a crazy error, you're centimetres out or
Yeah.
more, then you've done something silly.
Yeah.
If it's a few millimetres, over 5, 6 millimetres, then it could need adjustment.
When
So.
you say it, you mean the machine on top of the tripod that we look through?
Yeah,
Yeah.
because here, if I turn this round, see the little screw in there?
Yeah.
Right, you get a little bar, and you can adjust that bar, which moves the crosshairs up and down. So you would correct your error when you're set up there.
So the cross O is literally
Crosshair.
that cross.
And then when you've changed it, you put that back to protect it. Redo the exercise, you should end up with zeros. All right, and if you don't,
And how
then
do you know if it should be left or right for the crosshair? Oh no, it's up and down.
it's up and down.
Yeah.
That one actually got left and right, and I don't know why.
Right.
Maybe it's because of the circle, but if you look at this one, you've got adjustment top and bottom, so you need to loosen one, tighten the other one to adjust the crosshairs,
Right.
centre ones, and the 2 top, bottom and top. But it's got adjustment left and right, and all it can be is adjusting that centre one. And all I can think of is
It was a sail.
it doesn't. It doesn't relate to the circle taking angles, which we can use it for later. All right.
I'm slowly getting there.
Yeah.
Having done one.
Right. So has everybody read this and booked it down? So everybody's a go at it.
Mm-hmm.
This is not A, back.
That's
That's a different level. So if you're using this one, use this one. If you're using that one, use that one. I've done it twice because I want to know. Because if you use it, that one's lower than this one, you're going to end up with readings. Right. So what did everybody get for this one?
1769.
Yeah. And you actually physically looked. You weren't sort of listening to the other person. And what did you get for this one? 1.8's fine. A millimetre. It's an interpretation between what you're reading. This is what I'm saying. You can read the meters, you can read the decimeters, you can read the centimeters. You've got to make the rest of it up, right? So I'll move. Well, you do.
No, it's good to hear.
Yeah, making it up within that much.
Yeah, that's
Making
what
up to-
I did for my constructions.
Yeah. So now I'm going to move as I'm moving the staff to that point, which is point B, right?
Yeah.
And then you're going to turn these round and observe that.
Yeah.
And don't touch the tripod, don't kick it, don't
trip
end.
over it, don't
And
do
just
anything,
check
'cause you
it's
have to
level
start
still.
again then, don't you?
You do.
Shall I turn it?
Yeah. Excuse me. Cheers. Ooh. Whoops, sorry. It's my fault. So you managed to get it round, focus it?
What was it, the focus, and then what's the one on the right?
It's horizontal motion. Slow motion, horizontal slow motion. And you can use, if you want to line it up, you've got gun sights, the little line along the top, so you can line it up on that to find it first, and then use the slow motion to move it left and right, and then focus, and away you go.
It's the little grey thing.
That's the button, you've got to push the button. Did you not push? Which one are you writing, this one or this one?
I tried both.
All right. Yeah, but you're booking, oh, you're doing both. Oh, I see. You know which one's which?
Yes.
Okay.
What do you do? The crosshairs aren't parallel for this one then?
Parallel?
They're not, it's left down a bit.
Is it?
in the
Maybe it's
crosshairs.
the
Wonky stuff.
Oh, it's a wonky staff then.
the staff that's
Yeah.
All right, let me straight up. So it's falling. It doesn't, as I said, it doesn't, it's not so critical this way, but it is this way. Is that better?
You're just doing that by eye and feel.
No, it's the bubble wasn't in correctly.
Bubble there.
The bubble wasn't in right. I pushed it in, so the bubble was throwing me out. Yep. Yeah. Is that better?
Even more now.
It's even more wonky. Oh yeah. I'm better off just holding it in my fingers.
There we are. Yeah, I'm hugging out.
And do you know what that was? Not pushing the bubble in correctly.
Ah. So I reckon you're 1496.
Have you read the right line?
Probably not.
You got to read the big
So
one.
This is the back. Is this the foresight or the backside?
This is the foresight. So this is if you were moving forward. That was back where you've come from. This is where you're going.
And this is B though now.
Yeah. So you write it on the foresight on the line B. Yeah?
Looks like it's just below there.
I'm a bit
Pass.
lost, not gonna lie.
Are you?
Yeah.
What were you lost on? The first
I
bit or
don't
the
know
next
how I
bit?
count how I estimate what's in between.
Right. The
They're going-
little blocks are centimetres, right?
Yeah.
So I'll read it in a minute, I'll show you. So all you're doing is guessing where that line is between
Yeah.
the blocks.
I'm getting
No.
1.45.
1445.
But I don't know
1446. Sorry.
So it's 1.4.
yeah.
And then
Yeah.
it's got so he's getting 1446. So that must be just above the halfway mark,
Just below
Yeah.
5.
Oh, I saw just below.
so it's 1.4.
Yeah.
Just before 144. Let me see. Excuse me.
Gotcha, yeah.
That's confusing myself.
David, would you say that's 1.45 or 1.47?
That is
4.47.
that's 1446.
Oh, did you get it?
This is how you do it.
That's not too
1446. So do you get that now?
Yeah.
No.
Oh.
5. 5 or 6. It doesn't.
Yeah.
As long as you're consistent in what you do, whether you're reading, you want to go to the higher one or the lower one, it's all right.
Yeah.
Right.
So are you basically checking one way as your back and one way as your front? And
No, it's the start is always the back sight.
okay.
All right. So where you start, and you set up the level. The first point you take is the back sight. Then we're moving forward. So this is a forward sight. And then you move the instrument. You're going to be looking back, and then going forward, and looking back and looking forward. And then your intermediates are the stuff in between, like it could be the top of the step, the walls, the gullies,
So next we're going to move that.
right next door, and then you're going to take a back sight
Yeah.
into there,
Okay.
and then I'll move this staff, and then you're taking a foresight back to A.
Okay.
Yeah. So this one. So that's 1497.
Yeah, that's what we got.
So you can read it all right. That's not an awful. Where's your man? Did you press your button to see what happens on that one?
Yeah, you could like load it with ammo.
All right. But the idea of just flicking the foot screw or touching this tripod or bashing the top is the same idea. As long as you get it pendulum, to get the pendulum on the wire and the prism to move, that'll then settle, and that's what you did correctly.
Can I press it? Can you press it?
When you're looking through it, yeah.
And then it finds its balance then, does it, basically?
Well, it is. It's hanging
Yeah.
through to gravity,
Yeah.
and the line of sight through the prism is going to be exactly horizontal.
Okay.
But that can sometimes stick.
Yeah.
So you need to be careful to make sure it bounces and sometimes. Because if it's stuck up, you don't know what it's reading.
Okay.
And when you do this exercise, you're going to end up with mistakes,
So it's
basically.
always worth
Yeah.
pressing the button.
You've always, on every shot, you should
Yeah.
press the button.
Okay.
So,
So-
can I just confirm, once you've spun it round, you can touch any of these things, it's just these and this that you
You don't touch this, you don't touch the foot screws at a time.
but then all the focus and
All this is all right, yeah. You just fiddle that about, all right? And then the intermediates. If you're doing intermediates, there's a check on this because they're change points. We're taking a shot back and a shot forward, and we're going to work these out, and we can check them. With intermediate shots, which go in the middle, you're only taking a single shot, so there's no check on it, unless you visit it on the way back, which was the sausage method, where you're occupying the same points. So if that red cover there, stopcock, was critical, because you want to check the height, you could level it as an intermediate now. You go around the site doing all the rest of the levels, and you come back to close it out on way, and you take another shot on it as an intermediate. You've got two levels on it, you can see how they compare. Yeah? So if you want you don't want everything as a change point, because you'll have so much, you're introducing your error because
When you
you've got to
say
put the stuff in it.
intermediate, You mean a point in between A and B?
Yes.
Something, okay. Not an intermediate, yeah.
It's not a control point as
Yes,
such.
it's not relevant to A and B.
No,
It's
'cause-
a point, yeah.
Because if I didn't use them as an intermediate and I want to take that cover, I'd need to put the staff on the cover, read it as a foresight, change the instrument, read it as a back sight,
Yeah.
and then continue. And if you've got to do that all the time, you're forever moving the
So
instrument.
sorry, if we did want to do that red thing, we'd have to put the staff on it.
Well, you put the staff on it as an intermediate, but you're taking one shot.
Yeah, you take a...
If you want it as a check shot, you would need to introduce it as a change point.
Yeah.
But you're going to be forever changing the instrument, taking shots like the top of step. You wouldn't change on that unless you wanted
Yeah.
to go inside.
Yeah.
So that would be an intermediate shot while you're doing everything else before you move the instrument. But if I was going to go inside, I've taken my back sight there, I've taken an intermediate on that red cover, I've taken a foresight to that,
Yeah.
right? But again, I'm going to move the instrument again, so I could leave that as an intermediate, as a checkpoint, Then put the staff in the front of the doorway, put a cross in it so I get exact same place. Read that as a foresight because I'm going forward. Move the instrument inside the building, read out there to the back sight, and do whatever I wanted to level in there. Come out it, change point on there again. I could then change on there to do some other work to go back on there.
Sorry, you lost me.
Right,
The
all
bit
right,
where you said I could then put it
there.
by the door or the whatever, and then
Move the
that,
instrument.
It would be a foresight.
Yes.
But it's not, because that way you've done is back.
No, I'm going inside now. I'm moving the instrument inside.
No, but before you went inside, you took a measurement.
I did. Measurement on that's the start point. That's the back sight. Level on that, intermediate. Level on that can be an intermediate, and on the gully and on the stop tap here, right? All intermediates. I could do the step as an intermediate
Yeah.
if I wanted, if I was staying out here, but I want to go inside. So I'll use it as a foresight, move the instrument, it stays there, and then I'm in instruments inside and I'm reading back to that point.
Oh, make it point B.
Yes.
Yeah, sorry. Okay.
All right. You know, don't get confused with A and B. It doesn't necessarily
No,
be an A
when
point.
you say foresight, that actually saying
Makes
it
that.
point B actually makes it.
Okay,
easier
that's
for me,
fine.
For my head, and maybe not
That's
for
fine.
somebody else's.
Right. So to move these now forward, you can check it's clamped off. You could, if you want to be safe, take the instrument off, put it in the box, carry it up there, put it on the tripod. But as we're just moving there, and hopefully we're not going to trip over, we make sure it's tight, shoulder underneath it, and just move it forward. Somebody can do the same with that one. Right, and somebody wants to, that's it, right, a bash it trying to get the top of it level. A bit, and maybe bring this leg up a bit. No, that way. That's it, fine, and then put your foot on them, just to make sure they're solid, and then you can level it up, alright? Now this one was tight on one of them, wasn't it? That one, I think, so we'll move it up halfway, so it gives you a bit of play, all right? And then you can continue trying to level it using your left hand thumb. So you want to move the instrument, as it says in your instructions, between there and there, parallel to these two telescope, and then it's going to move the direction of your left hand thumb. So the thumb wants to go that, but you're doing them both at the same speed. Both at the same speed, so you're going away or together. No, away or together. That's it, go more. Right, slowly, a bit more. Slowly, right, stop. And now you can use the left thumb for that, and that wants to go that way, so your left thumb wants to go that way. Go on. Yeah, there we are. And then a little bit more on these two together. There you go, job done. Doesn't seem so hard then, does it?
I don't understand how this, we're now going to
Sight this one,
move this one back to,
after we've observed it.
from where?
So you do a back sight to that.
This is the back sight now. We've moved the instruments, the back sight to this point,
Yeah.
and then I'm going to move it to the foresight way down there.
Hang on, put it here, and then we're what measurement are we taking from here to A?
A back sight to B.
To B?
And then a
From
foresight,
here?
and then
Yeah,
a
you've got
foresight
it.
to A.
Yeah.
Yeah. So,
So we're doing what we just did, but in reverse with it in.
Well, we're doing exactly the same setup, but it's just the staff's in the same place, you know. So you can imagine that was A, and this is the first reading I'm taking.
yeah. But then why?
Well, let me finish it all, and then a bit like it might be a bit like the staircase
Yeah.
or the steps, shall I say?
Here we're obviously super close, so I don't
Yeah.
know why we bothered going in the middle and why wouldn't.
No, because we're trying to find the error within the instrument.
Yeah.
All right. Now that, as it happens, is very convenient because it's right on the top, but I don't know what right on the top is. So I can see a little pencil mark at 1.44, and that reads 1.450. See if you can have a look. It's quite difficult. 1.450. Yeah. And if you look at one of the videos I did, I've got it so close that I can't see anything. All I can see is a big dot. So I use a bamboo stick going up and down to try and find out where I'm to look through it, because I've got nobody else to help me.
This
Otherwise you go up and down with your finger. This is the back sight onto B.
How would this work? Is this all like a really tiered garden?
No, yeah, no, all we're doing here is we're trying to find the error within the instrument. So accept that at the moment, all right?
We're not actually levelling.
No. We're proving the instrument.
We're proving our instrument.
Because this distance now is a multiplication of that whole distance. So we've got 10 times the error. So if there's any error in it, when we set back on the original one, A, we've got 10 times the error that we had here. Did you read it?
1437.
I haven't seen it yet. Can you see the numbers all right? Because otherwise you need to get somebody to put your fingers up and down.
Okay, yeah, we're using the exact ink marks on.
As I say, if on the video I've got a bamboo stick trying to move it up and down to see which numbers I'm reading. Yeah, it can get tricky. So again, as I said in there, I don't know if you remember, you would only survive within 5 metres of the instrument and then up to maybe 20 or 30 metres. If you want to do any closer than this, you would do it from somewhere else, right? And because you're doing it very close and very far away, if the instrument's not in adjustment and is good, you'll get big errors. So we want to try and minimise this.
1436, is
I think he just says one more on one less than you said.
The white is the 4 and the pink with the pen mark is the 5.
Calm down.
Yeah,
Don't give me this.
reading it fast, I like it.
145. Have you seen it?
I didn't see you flick your foot screw though. I didn't see you flick your foot screw though.
Wow, you
1437. 1438, 1437. What did you get?
1437.
I didn't know.
What did you get? I bet you're out
But-
by a millimetre again, aren't you?
But you need to make sure that it moves.
Right.
If you don't do it every time, do it every other time, because if it sticks,
Yeah,
you're
you
not
get
going to
error.
know.
Yeah.
You're going to be reading wrong stuff. So you need to make sure that that floats. If it's got, as I say, a dumpy level, which is split bubble, you need to level that split bubble every shot. These ones are automatic level because it should be automatically leveling to the horizontal. But to make sure it doesn't stick, you tap it or press a button.
So on this one, what are you doing to tap it? Which are you tapping?
You could tap it. You could try
just
tapping the
wiggle
top of
the
it.
screw.
I just wiggle the foot screw because it's easier to make it go up and
And then
down.
you can check the level very easily again. Yeah.
Yeah, because as long as you move it quickly forward and back,
And you can
it's going the
always check
same place.
Yeah.
It's just getting it to go up and down. Right, everybody, what do you read on there?
1450.
That's it. Yeah,
Have I put it in the right place?
that's it. Correct. So if everybody's read it, I'll now put it down there. Focus that. That reads now as a 4 sight onto A again. And once you've done that, add up your back sights and your 4 sights.
So we'd be pushing that.
Yes. All right.
Yeah, why can't it just go in this square here and it has to go in that square? No, because it's the white.
It's 4 sight because we're going forward.
Yeah, but can we not put it there?
No, because that's onto A. It's not the way you do it. You do one. You go like this.
Yeah.
Otherwise, you'll confuse yourself. You all right? It's flowing. The figures are going down the sheet. So why would you want to push it way back up the top? All right.
Because it's always the first measurement you take.
Right.
One in focus.
Is it tricky? You got it?
Yeah, I got it.
Did you look at the bottom?
Won't say it out loud.
There's one bottom, there's a left.
Right, so now you've read that, you can add up your back sights and add up your foresights and tell me what the difference is.
Wrong square.
Oh, no.
It's A back side, isn't it? Is that right? Oh, sorry,
Full
E
side.
side.
No, this is the second measurement you've taken, so it's going to
Could we do B twice so it spells out?
Has anybody read it? Both of them?
No.
Not yet, no.
be. Yeah, I have.
Oh, oh, we're getting serious.
There we go. 3 millimetre difference.
170.
What'd you get?
3 millimetre difference.
Fine.
Reasonable tolerance?
Yeah, it's fine. Because again, there's an element in reading it, setting it up, the staff positions. I've put it in cross on top of the end of the tape because I want to take the distance. So there's an element that might be a couple of mil different anyway. So it's within, as I said, anything less than 5 mil I wouldn't bother.
Yeah, it's right. Oh my word. No, no. It's there.
What was the oh my word for?
No, because I've got my points in the wrong place, which doesn't help.
And then we add up, once we've got them, we add up our backsides.
Yeah, yeah, yeah. So your last observation's going in there, yeah. So you can add up that lot.
Yeah, I'm confused now about my numbers and why I'm getting it wrong. Not wrong, but like the point in the wrong place.
Or you just do total.
Yeah, so
Right,
I've
let me
done
read
something
it.
wrong, haven't
All
I?
right,
Because
all right. Let me just read this first, then we can work it out. Oh.
Ooh, 6 mil difference.
1720.
So this one's dodgy now, it's 6 millimetre difference.
Right.
is it? I've got 17.69 there, but it's actually 1.76. Yes.
Yes.
So I had 1719, and so then I've got. I'm
One
adding these up,
point
Yeah.
four.
and it's
3 millimeters.
yeah.
That's fine.
Yeah.
Whereas before they'd 6 millimeters. So, and I've put that end to where it was previously. I've put the end of the tape under it. So the end of the tape's probably 2 or 3 mil.
Oh, okay.
So that may
Which
even
accounts for the
it could make it
difference.
worse or it could make it better.
Okay.
Yeah, but that's fine. So
Okay.
you would accept that level's fine to
Okay.
use. All right.
So, Have I got it wrong? 1497, 172.
That's fine.
I've got 3.117. Have maybe I've added that up wrong. I've got to write this out again now
Do you want me
because.
to?
Add these two. Add these two.
Oh, you could do, but I can't do it. 11.
Yeah, I've got 2
12,
mil
1, 2.
on my one.
I've got 3.219.
And I've got 2 millimeters. Right. 217, 219. So you get 219's correct. Where's that
Yeah.
from?
And then
That's from that
those.
side.
No, it's
And
that
this side?
Oh.
1.497, because that's wrong.
Measuring this.
And then 1720.
1720.
Measuring here.
7, 9, 10, 11, 7, 8, 9, 10, 11, 12, 3,
So you're
2 millimeters.
You're 2 millimeters out.
See? You can do it.
So that's
Yeah, have you sussed it?
Yeah, I'm 1 now.
1 mil. Well, even better. Yeah, which all we're trying, as I said yesterday, I got 4 mil, they got 6 mil. We've got 1 or 2 mils, 3 mil. So that level is fine. all right? And that has never been adjusted, as far as I know, any time.
No.
And if I was going to adjust it, as I say, you
Move that bit.
move that little bit and you would adjust that last reading, because that's the only reading that you can see. It's the only one that's live
By 2 mil.
by 2 mil, and it'd be crazy. You couldn't.
Oh, not
It'd be a bit silly to move it by 2 mil.
If it's, sorry,
If it's 5 mil and less,
yeah, sorry.
5 mil
five.
plus.
If it's 5 mil or less, it's fine. If it's 5 mil and upwards, you know, if it's 6 and 7, I would do it again because you might have just read it wrong. If it's 10, 20, 30, then one is the little thing is sticking and it needs to go to the manufacturers,
So measuring this is
or
constant height,
um,
but because the ground may not be level,
it's just stuffed.
that could also.
But if you've read it, if you do the exercise twice and it still ends up 20 or 30 mil, and when you press that button you see the compensator going, there's something seriously, it's had a serious bash or the crosshairs are miles out or something. But it's not reading what it should do, all right? But this would be fine to use, and I would continue using it for a job. And if you used it quite a lot in a job and didn't use it for a few months, then I would check it again. The next job you use after, if you look after it and it doesn't get kicked about the car and all the rest of it, I wouldn't bother checking it. But I would certainly do some checks as you go round, like that cover level, take it from here, take it from there, take it from there. You've got three or four levels on it, if they're all good, because you're going to have different distances, like your observation here or observation far. If the levels are still within 5 mil or something, so fine. Yeah?
So if you were taking the level of that wall, you'd have the bottom of the stick on the wall and the tripod all working it out. And then you could come along and go measure it with the tape measure.
Physically measure it as a
Physically
check.
measure it with the tape measure and
Yeah.
say, oh, but then you'd have to take it from 2 places to say
Yeah,
that's
but you can. You get the hang of what you need to do and what you don't need to. What's this one like? You said was 1 mil.
I got 6 mil.
6 mil.
Yeah.
And anybody else got what?
4 mil. 5.
Right. Did you flick your foot screw? 1702. What do we get?
702. There we go, you see. 1446. Yeah, look at that, you see.
1701.
6 mil.
6
Yeah.
mil.
Right.
Millimetre accurate. Look at the same numbers.
So yesterday this one was good and this one was bad. Right? It was the reverse. That was a few mil. That was 6 mil. Where I've got the staff, I've put it on top of the end of the tape, so it's probably 2 or 3 mil. So that 6 mil could either be better or worse, depending what I do. But it's still within, it wouldn't need to be adjusted. If come next year, and that's getting up to 8 mil, then I'll adjust it. And I'll take off this and adjust that one, loosen it and tighten that one to push it down.
What changes the measurement on it over time? What is it why would it change?
Well, it's cold today. You know, so
Okay, so
temperature
it's
might have
actually-
affection on things. You know, it'll certainly, anything that's metal, so there's an aluminium staff. So even though we're measuring, you know, it's going to change. I mean, it's not changed from when we did it this morning. We've only done it with the last hour. But you remember the temperatures, everything that's metal is getting changed. And then you've got your observations if you're always reading high or always reading low. So now what we're going to do,
But over time, let's say over a period of 5 years, what would
it shouldn't change unless it's been bashed about. It shouldn't change.
Also, if it is expanding and contracting, then gradually that can cause bits and pieces to move. So if you've got any
Yeah.
screws that are tightening, they can tighten and loosen.
Yes, that's
move
it.
a little
But it should be a compensating error. So providing you've got equidistance, so when you're generally doing levels, you've got a reasonable distance before and after. This is too short to read, because if you're on your own or even with a staff man, it's too short. So you'd want to have a minimum distance probably of 5 metres. So you could read as far down there and 5 metres down there. You've proved it's 6 mil on this and 2 or 3 mil on that. The error on that's nothing, and the error on that's now less because you're a proportion this way. So the object of taking levels at this distance is fine. I wouldn't reduce it any more than that, and I wouldn't shoot it any more than that. You could probably push to 40 metres, but I wouldn't do a lot more.
Would a surveyor ever share this with the client, as in the ground design?
No, because if he's going to share that, he would share all these other information. You get too much. So, but if there's any queries on any of the stuff that you're checking, he should go back to his field work and just see if there's anything gone wrong. But he wouldn't publish it to you. It's confidential to the business. But certainly, as I said, on GPS, on drones, on laser scans, they need to take one or multiple shots on something at different times to prove that's what they say it is. Because again, drones and GPS are in curvature of the earth. What we are using here is all on the flat. So you're going to get introduced errors. So now what we're going to do is going to read the bottom here and take that away from the top here. All right? So we'll read the 3 hairs. We're going to read the bottom, the middle, again, and the top. Right? And when you take one from other, multiply it by 100, that should be the distance. All right? So the crosshairs, there's little tiny crosshairs. Right?
Yeah, I remember those.
So the bottom hair on that is 1550. And the middle is 1702, which we had. And then the top is 1855. Right? But don't take mine as read, read it yourself. Make sure you move it up and down.
So this is the distance between this and point.
Yes.
whatever that is. But
Yeah.
we haven't actually located this because B's back there.
No, all we're doing is the instrument's set up here. If we were going to do observations, like level points all around here, and we didn't want to measure it physically like that, we could use the instrument and the staff to give us the distance to that point. And then you can combine that with a circle and you get an angle to it. So all the different points you could do, giving you the distance and the angle, and you can then plot it on your plan.
Okay.
All right.
I'm getting there.
So, but this is only accurate to 100 mil because it's a millimetre is all you can read.
Yeah.
So a millimetre times 100 is 100 mil, so you're never going to get better than that. But it's certainly good enough for doing quite a lot of stuff and checking stuff. So not only do you use a level to check your contracts, the engineer's work, if you set up your level at the corner of a manhole and you measure that manhole off of some known bits, and you then set the 0 on the circle to the corner of the building, you can then check some of the contractor's bits, not only the level, but his positions.
So here, are you saying? Sorry, I'm going to sneeze.
Bless you.
It's if we move this to on top of a manhole, we can now start taking our measurements.
Angles and distances. But you need to reference it.
So this this is our first reference one. No.
I'm only doing it to show you the distances at the moment.
Okay.
All right?
So what are we measuring with the bottom and the middle and the top? What are we measuring? Oh, I guess we're measuring an angle so we can work out the distance from it.
No, the stadia here on the instrument is set up at a set distance, and when you read it on the staff, you can multiply that by 100, and it will give you the
Yeah,
distance.
because of the fact you've got angles involved, you've got a slightly.
Well, no, it's all flat. We can use a theodolite. So if in the old days you used to use a theodolite to do it.
What I was getting at was to get the distance measurement.
Yeah.
It's because of the fact what you've got is you're effectively doing this,
Yes.
and so
that's
you're
it.
measuring this bit here, and then that's calculating this. This is what you're trying to calculate.
That's it. Yeah. But in the old days you used to be able to do this.
Yeah,
Right.
that would make sense. Yeah.
And then you had the staff up there. So the differences between that and that are different depending on the inclination.
It would be.
So you would have a thing called Redmond's tables that had the angle against what
Or you do a bit of
factors.
trigonometry.
Yeah, to work it all out. But it used to be quite time consuming.
Yes.
So you had to write it down to correct your horizontal distance, but then you get your level.
Yeah.
Oh, it's quite clever stuff, and it's not expensive, and yet you can do quite a lot with it.
And I presume nowadays you just put the XYZ coordinates of points into the software, and everything is an awful lot easier.
Yeah, but more expensive. Because
Yeah.
you've got to maintain the software, and you've got to.
Yeah, but when it comes to then doing the number of calculations and the risk of error in
Oh
the calculations
yes,
themselves,
of course. Yeah, then you would
the
use a bit
problem
of
is,
software.
we were just talking about this earlier. If you're trying to do your slope distance versus your level distance, you could easily use the wrong one at a particular time because
Yeah.
you're getting confused when you're doing something
Yeah.
distracts
Well,
you.
I've got an Excel spreadsheet that I put on the handouts that you can punch in your difference in height, and it'll give you the horizontal distance. So it's helpful.
That's the kind of thing where you could easily use the wrong figure from it because you're just reading something off without thinking it through.
Yes, that's it. Yeah.
Whereas, let's say,
And you think it must be right.
yeah.
Yeah.
Whereas you've got your software, you can actually say,
Yeah.
no, I want the flat distance, and
Yeah.
give you the
Yeah. So, what is it here then? So it's 0.5503. So it's 30.5 meters.
okay, 31 meters.
31. All right. So
What numbers did you get?
I got 1550 bottom, 65. 1702 is the middle.
Yep. Oh.
Oh,
we must have moved it because I got 1702 last time.
Oh. And then
Oh,
1855. You got
No,
75.
no, the 1702 was on this one.
Yeah, that's
I
right.
was measuring on this one. And
Okay.
that's the difference. Look at that. See, look. 15. There's
Yeah.
your difference.
Well, I haven't done
distance.
that one yet.
There's your distance.
Yeah.
There.
So you said you was. What's your distance you got?
31.
So you multiply, you add it up and multiply by 100.
Yeah. So we're saying, is that about the centre? Well, if I've got 95, so again you could get a little stone or something and drop it from the end of there, and it should be, so it needs to come back.
Plumb line would be useful.
Yeah. So I'm getting 30.86, 30.87.
15 centimetres out. It's a bit far.
Yeah, but again, it depends on your millimetre readings, what you're going to get.
Sorry, you said add all three.
Take the bottom one from the top one,
Oh, okay.
multiply it by 100.
Oh, mine.
But it's useful, and it's quite, it intrigues people that you can use this to get a distance, and it's not that far away. I mean, it's far away from what we are concerned, but it's useful for checking things and putting levels out.
It's just a bit of a trick.
And if you're accurate and you don't have it too far away, you can get your millimetre
Your
correction.
100 times things only an approximation. So you're
Best you
gonna
can
get a
get.
good distance from it.
Well, you can get an exact distance if it all works out, but the worst you can get is 100. Well,
Well,
the
no,
worst you can get is you can get anything 200 or 300 mil.
Because you're just multiplying by 100 would depend on how far away you are as well. Your factor wouldn't be 100; it would be slightly up or
All right.
or below because
Well-
it's just trigonometry.
Yeah, well, that staff is a 5 metre staff.
Yeah.
I set out in Zambia a kilometre, right? Because I read the top hair. No, yeah, the top hair was on the top and the middle hair was on the bottom, right? And that's what I could see. So that's half the staff. So if that's assuming a 10 metre staff, and 10 metres times 100 is 1,000 metres. And I checked that 1,000 metres and it wasn't that far away. You know, it was, all right, it was within a metre, half a metre, but it's still very good over that distance.
The problem your problem if you get close from a long distance, your triangles are broadly the same shape.
Yeah.
If you get close, you're suddenly starting. Instead of getting this shaped triangle, if you get
Yeah.
close, you're getting this shaped triangle.
Yes.
And then you're going to get a big difference. So it's going to be accurate so long as you're a long way off.
Yeah. Well, it's still good enough.
We're 31, which is actually
Yeah, that's what
10
your man
centimetres.
had.
31.
So what was the
too
difference?
short.
Oh.
10 centimetres wrong.
Yeah, but still,
And that's
that's
okay.
100 mil. 10 centimetres, 100 mil.
Okay.
1 millimetre.
You're measuring slightly up, slightly down. The reason you can get a height is with trigonometry.
What is this one coming out as?
30.5.
30.5. So that's probably about right as well, isn't it? So 1550. Oh, that's what I got. Yeah, 30.5. So if I so you're probably about there somewhere, I would say. Yeah, 30.55. That's 5 centimetres out. Assuming that's more or less there, yeah. So it's good. All right, so we're able to take a distance with this kit, and we're able to take levels, and we've proved it's working. So now you can crack on. It's crazy. But yeah, so you can all do it. So you can read a staff, you can make sure the instrument's all right, you can press a button, flick a foot screw, tap the top of it.
What does the button do on
You want to tap the side of that to get it, because you can hear it. You can't hear anything there. You can't hear it. Well, you get a little bit, but again, there's a danger of putting off. But you touch the side of it, you can hear it move. But I still prefer flicking the foot screw. It's much more controlled.
the button do on that one? this one? Because this one doesn't have.
That's an older instrument. They decided that if you push the button, it makes the whole image float up and down. So that's doing the same thing. Move it on the staff and you see it float up and down. Is tapping it any good?
Yeah.
The trouble is you're moving the instrument off because you're tapping it too hard to get it to move.
Oh. Okay.
Twisting the foot screw is by far the best way to do it, to get it to jump. Right, so that's us done a leveling. We've shown you how to do a distance with the level. Now we've got a grass area out there that we want to level, and it's a big area. And we've got two choices. One is we can use the instrument that we're talking about here when using this circle, and using 3-hair stadia as we did to position the levels. All right. The alternative is to set out a grid. And if we all go this way now, I'll show you how to do that. Now you're going to like these. So I've got 2 of these, the third one got bashed. And what it is a right angle square. If you look through the orange or the yellow, it's straight ahead. That one is that way and that one's that way. Have a look. Another one. And the very handy piece of kit's 40 quid I paid for it. You can get them service advised for about 80 quid. And it's a good, useful tool. So it's an right angle optical square, or double prism optical square.
Yeah, so I can see you in it.
Right? So if we all come down here.
Yeah, you can stand here and you can have a look at the corner.
I'll wind up my tape. Right, what I want you to do is put one of them optical squares on the top of that and set out 2 poles, ranging poles that way and one at 90 degrees that way.
Whack it in the ground.
Then whack it in the ground. We're now level with Duncan, I think.
Yep, and now you do Ellie.
Ellie needs to go to her left.
Just put your foot on that, please.
On this.
Yeah,
Here.
just that's
Ellie
fine.
go.
Yeah.
Stop. Okay, now straighten the pole. No.
Right, so what I'll do is I'll move that to 5 meters. Oh, I just want to demonstrate.
I don't know though. Somebody else.
That's it. Thanks. All right. So.
Hang on.
All right.
No, sorry, I meant hang on, Michael, not hang on, David.
Right. So has everybody had a look through this?
No.
Not yet. Is yours in the right place? If it is stuck, you stuck it in the ground. Yeah, that's fine. So that didn't take long for somebody who's never used it to set out 3 poles, 4 poles. Yeah, very quick.
You need a friend, don't
Of course, yeah. But you could do it yourself, but it'd be a bit of to and fro.
Oh, I see, yeah.
But anyway, you can easily set out a 5 metre distance. You can put that back, oops, you can put that on there, and then you can go right angles again. Is it still in one piece? Yeah. And then you can put it on there and you can check the last distance to make sure it's square. And the thing is that this can be 5 metres or 10 metres or 50 metres or 500 metres. As long as you fix that against some points of detail that you've already surveyed, and the other end of it, then that becomes a rigid square. And then all you need to do is put in bamboo canes at 1 metre, 2 metre, 3 metre, 5 metre, whatever you want, put them in, and once you've gone round it, the ones in the middle you'll be able to put in very quickly. So you can establish a grid. Then you can take your level staff and just visit these points really quickly.
You said set it off against something.
Well, you need to know where this grid relates to the building.
So
Yeah? So you would,
triangulate this point basically from
yes.
And then most of those levels you're taking at the points on the grid, you're treating as intermediate points. So
They're
you're
all
taking
intermediates, yeah, they're all intermediates.
taking one-
And ideally, if you had a big grid, you'd set the instrument up in the middle, have a back sight somewhere, and you're just going bush, 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 bush to them all. And you can number them 1, 2, 3, 4, 5, or you can number them as 0 east, 0 north. Then the 5 metre one is 5 metres east, 0 north, 10 metres east. You go up one, and then it'd be 10 metres east, 5 metres north, and work your way back. So you could work it out like northerns and easterns, which may be easier than 1, 2, 3, 4. But basically all you're doing is relating the grid, numbering it on a sheet, setting up your level, having a back sight to a known station, and just going through intermediates one after the other. And you get back to the office, you reference it to your plan, you know the orientation, how far it fits. Once you do that, put little dots in between it all and just put your levels on it. Job done. However the land goes. But the advantage of this thing as well is if you move out the way, I can go on the edge of this line here, right? Can you move it? Yeah, thanks. So I can line up the edge of this line against the edge of the building, right? And I know that if I produce, oh, I need to do the screw. If I produce the line down from there, I know from that point of fix it's only about half a metre, whatever it is through there. So I've proved the survey because I know that alignment there comes to here, comes to there, and it's that distance off the edge, and I can check it against the survey. All right? Yeah. So it becomes quite useful and quite quick to do it.
One of those things we could get, and we can check someone else's survey with it
Yes.
without having to immediately get out that.
Well, it's easier. I mean, you're going to, yeah.
No, you can't do levels, but it's a good place to start.
Yeah, but if you get a survey, you want to check how good it all is.
Well, that's what
Yeah.
what I'm now trying to work out.
Yeah. So you can use these things
Yeah.
and using your eye and taping the building from there to here and from there to there, and you can check, is this parallel to that? And once you've established it's parallel, you know that the right angle, say here to there, you can then measure that curve one way or the other, and then you can then take it from, you know, you fix that point because you know it's parallel, you can then measure from there. So this becomes a baseline or your control. So you start building up the survey with all these measurements. Yeah? Okay.
Cool.
All makes sense?
Yeah.
Well, that is about it. So thank you for your time.
Survey of the site. What is the order in which you would do things? Would you do the boundaries first? Would you?
I'd think about the control element, where you wanted your baselines,
Yeah.
because that's what you're going to measure
So
off,
you
or
get-
control
so establish
points.
your control first.
Yeah, so establish control, and you'd put this here and there going up there, and if you had, I don't know, the boundary around this tree and over there, then you could pull a tape from there, bang in a peg, and then a tape from that end, bang in a peg. You've already measured that distance, so you now get 3 distances. You've got trilateration to that point, and then you can move a tape from there to there and do the same distance down here.
Would you measure the boundaries before you measure anything internal? to
You
the
work
space?
from the outside to the inside.
Outside to inside. That's what I was getting at. Yeah.
Yeah.
Okay.
So that's how you'd work it, yeah. Yeah? No? So yeah, so it's just building up the measurements and then taking some additional ones to give you confidence of what you've already measured. All right? But that's it. So if we take everything else and put it back in the office, that's us done.
Thank you.
All right.
So to capture each level, you need to arrange the staff onto it to capture.
What if you were doing this grid?
Yes.
Yeah, so I would, once I've set up my instrument in the middle, I've sighted back to there. This is my first point, so I just hold the staff on there, read it, book it down as an intermediate, point number 1, move it to there, observe it, point number 2. So you need 2 people, and then you can just work your way around it. Yeah?
Okay.
Thank you. Cheers. Yeah?
So the bottom of the staff.
The bottom of the staff.
What are you reading though? From?
Oh, well, it's on the top of the grass. It doesn't need to be on anything because it's soft detail.
Okay.
So whether it's there or there,
Yeah.
your survey is never going to determine, because you're going to plot, you're going to put your levels on it probably to the nearest centimetre. You wouldn't do millimetres.
Okay.
You do millimetres on hard surfaces
I'm thinking like,
and your control points, but everything else would be 2 decimal places, because you can't do better than that. Because, you know, if I take a level staff there and measure it to 3 decimal places, and you came out to use that to do something else, you couldn't guarantee that you get the same place. So it needs to be. So this is what I'm saying about the contractor might use a point there that you've written down to 3 decimal places. He think that's very accurate, so he'll use it. If it's 2 decimal places, he'll have less inclination to use it. He would use it on the corner of that because it's got 3 decimal places, and that's a solid point, so that'd be fine. Yeah.
Yeah.
So it's horses for courses, but soft details always 2 decimal places. And it just depends on the grid. I mean, this is slightly undulating. You're going to stick them all back in the office, yeah, thanks. Yeah? All right.
So there are a lot of these second-hand on the market.
You can get,
Companies are getting rid of them.
yeah, companies might not use them, but you could pick up a second-hand tripod, second-hand level, and a staff, maybe for 150, 175 £175.
With the angle thing on top, but can you just, how are you taking the angle?
Right. So, right, if I explained here, right, so let's say I wanted to grid that level, do the levels on there using the instrument. I'd set the level over here, I'd get a plumb bob underneath it so that I can get it more or less exactly over that nail. Right? So a little bit of fiddling about and get it right over the nail, right?
Okay.
I've set it level. I would put the staff in the corner away over there and read the distance by tacheometry. And remember, you've probably measured that, so you've got a confidence check because it's going to be better than 100 mil, or should be around there. So you take the distance to there, you set 0 on the instrument, so you can turn that circle around, set 0. Then you can check onto this corner, and that'll give you that angle. And again, you can physically take that distance. So you've now got the distance to there, the distance to there, the angle is 0 in there, and the angle whatever it is to there.
So I see. You turn it from 0, and then
Yeah, and then once you've set 0 in there, that doesn't move. So the instrument will move round about. It's 0 still set there. You don't set it again. Don't touch it. And then you can go bush, bush, bush to as many points you want.
What is it that you're reading? Because it didn't look like. Is there like a little nick that?
What, in the instruments? Yeah.
Can I?
Can we take all this stuff back? You might as well. Yeah, lovely. Yeah, you can only read to sort of, I think it's 20 minutes of arc, but 20 minutes of arc's fine, because you can never read more accurately than that with a level. You can get down to seconds of arc and tenths of seconds of arc, which is very accurate stuff.
But I'm not sure how it goes in.
All right.
I want to mess with it. Did you turn it upside down? I didn't want to.
Yeah, it goes upside down, that one, I think.
We're just going to look at it though. Hang on.
You're going to. Oh, sorry.
It's all right. We're just looking at angles.
Yeah, that's fine.
No, you haven't done anything wrong. I've got my foot on that. So let's
Right,
say.
so this one, so you've got a little line on there. So you would
that's the nick that you read from.
Yeah, so you would set that on 0, right?
Yeah.
And then every time you turn round,
Yep. Okay.
you're then reading off the angle as 3, 2, 1,
Yeah.
40 minutes or something.
Yeah.
And on that one, or the other one, should be similar.
Yeah, so I was thinking there must be something like that,
Yes.
and there is.
That's its
That's
sussed.
what I wanted.
All right.
Yeah, yeah. Perfect.
So I'll put that back in the box, and that's us.
Oh, and this must go in the red bag.
Yes, thanks.
And yeah, she would get organ. Get organs and blood, yeah.
Well done.
Stays on, does it?
No, I'll take that off
I
because
did wonder. I didn't think
No,
that
that's fine. Yeah.
packaging goes.
and it's not ideal because that's why it was wibbly because I didn't set it in far enough.
And then you just have to protect that somewhere else in
Yeah.
the bag and not lose it. Then.
Yeah,
Great.
and they get lost, they get bashed. So yeah,
Well,
the
then
great
you go
idea.
out on site and you go.
Well, this is the idea of
Where is
moving the staff back and forward so that you can get
Yeah.
the lowest reading.
But you have to, make sure you've got every single piece, isn't it?
That's right. Lovely, thank you.
In the bag.
Yeah, that's fine. Ta. Right. It's a bit warmer in here once you've been outside, isn't it? Okay, everyone. So, did you learn something?
Yes.
Good.
Yes, it was all new to me. So.
Yeah. Well, again, if you, as I say, this video is going to go. I'm going to put it on to my YouTube, and then I'll give it to Marco, so you can go back and listen to it all again. And I might fill in a few spaces, and
Yeah.
the one I did yesterday as well, because I did, each field exercise, each lecture, I talk about slightly different things, so it's worth listening to. But anyway, well done, everyone. At least you did it all. All right.